Welcome to Analysis and Design Week 12. The topics for today are package diagram, component diagram, and deployment diagram. Let's have a look at a class diagram enriched with some packages. You see that we have three packages over here. On the left side you can see that they are the source packages, for example, from a Java application. Could be familiar kind of having a president service, a simple president Java file, and having a data service layer with DAOs in there for the database connection. And you see that these classes are put into these packages, kind of that these classes belong together, and you can structure that by putting it into so-called packages, which you should already know from Java. So look at the package diagram. You could also draw a package diagram without classes and just show the dependencies between these packages. And this gives a more higher level overview about your application, about the structure of your application. So due to the purpose you're drawing your diagram, it can be a good idea that you just draw a package diagram to give a rough overview about your application. And you can leave out simply the classes, but still have an idea how your application is structured. How does it look like? So you can have on the left side the services where you have no members actually shown into a package. So this is just a package name, services on the left side. Just write it in the middle. If you don't have anything inside that, you can have the package services again, and then you write the name on top of the tab. And if you have another members in there, in this case, two classes, application config and president service, you can do it like this. Or you can have also packages, in this case package type, and again you have a sub package in there, temporal, and in there are then, for example, classes, so you can have it nested. You draw dependencies between packages. So if in a package A, if there depends something on package B, and this is the case if A contains a class which depends on a class in B. So in this case, for example, in the presentation layer, if you have here a class which needs a class in here, then you generalize that by simply saying, okay, there is a dependency, because you're not specifying any further how the dependency is, or is this really a dependency between classes, where dependency, remember, where it could mean a usage in simply in a return type or as a parameter or inside a method. So no instance actually inside the class created or saved, right? Because you don't know more details about the kind of dependency. Is it really one class having an instance of another class from these packages? And then you simply say, I have a dependency. Fowler says cycles in dependencies, they should not cross tiers. So you should not have any cycles like this. Yeah. So inside these tiers, you can have some cycles. Also, cycles should be assigned in general to have a look at that. Maybe there could be an issue in your code, but don't have cycles to cross tiers. So besides having a good structure, putting classes into packages for the structuring purpose, it also defines a namespace. Remember in Java the visibility of classes, package visibility, and this of course makes then sense. So if you have a specific visibility defined on your classes, you can make use of that if you put classes, structure classes in packages. So now the question, which classes to set into a package? If specific classes, and I told about if they belong somehow together, and this belonging somehow together may be due to domain, maybe also due to having a lot of dependencies. So these classes, are strongly bound, working together. They have many dependencies. One class is pretty often using the other classes. This may also be a sign for putting these classes together in a package. So logical composition of classes could be an idea. If you have layers, so group it somehow. And Robin C. Martin says common closure principle and common reuse principle, so reusability of things. So it's kind of a structuring thing. Reuse these packages, can easily kind of take these packages out. Grouping at compile time and many more. So this was about UML package diagrams. It's a very useful tool to give a rough overview about your application if you leave out the classes, but also if you have classes inside the packages to see how you structured your application. Next topic, component diagram. So the component diagram, so here you can see an example. You have a transport app with a REST endpoint using another component through this REST endpoint interface. You have the transport service in the middle using a JDBC interface of the transport database, which is a third component. So you can see which component is using which component through which interface. And this is actually the main idea of a component diagram. So you see the components and the interfaces and which component uses which one through which interface. Then important is of course the question, what is then a component? So customers want to relate to software, and components are about how customers want to relate to software. Actually, it is a software piece, which they want to buy. So the component thinking is, okay, I have a kind of a piece and I want to be able to upgrade that. So if I buy a piece, I want to upgrade this specific piece, this part. This is, from a customer perspective, the idea of a component. I want also to let pieces work together. This is also what I would usually want to have if I use components. I want to mix these pieces as well if I want to. Compare this with automotive. If you have a car platform which is in automobiles used for multiple car types, or you can use engines actually in multiple car types. So you have an engine which is a 130 PS engine which is used in multiple Volkswagen cars or multiple BMW cars. Same engine. So this is kind of a component which you can use or reuse. Another definition from Clemens to Supersky. Actually, a component is a unit of composition, so it can consist of multiple composed pieces. It has specified interfaces and it has a context dependency, so it's bound to a context. And you can deploy it on a machine or in an environment independently. This is the definition, and still you can ask, okay, but what size is it a component then? Is it small, big, huge? What is it? And the answer is actually it depends. If you see it, if you have a look at the specification of or the definition of a component, you can ask yourself a question: is a class, a single class, can that be a component? And the answer is yes, it can. So the public methods are the specified interface, and you may need multiple other pieces from Java or frameworks to run it, yes, but it can be deployed independently. So it could be that you have a class which could also be pretty small, but having a specific purpose, can be deployed independently and has specified interfaces which were offered or used by this specific class. So yes, it can be a component. Think of, for example, microservices, where you define this component, the functionality in a small class, and yes, it's integrated somehow, but can be updated separately, can be deployed separately. This could be a component. Next topic, the deployment diagram. So I have a physical layout of my software, actually. So physical layout means if I am ready with my software development, or I want to test my software, I need to run it somewhere. If I test it locally, it runs on my local machine, but actually it runs on real hardware. And inside this hardware, there are some environments inside my application is kind of running. So imagine a Java application. This is running on my hardware machine, but also running on the Java JVM, for example. So deployment diagram models physically the artifacts which you actually usually create and where they are running on which, and you say nodes. So there are two types of nodes which we have in deployment diagram. The first one is a device node, for example, simply a machine, a server, a computer, and the execution environment node. So for example, operating system, an application server, database management systems. So nodes can have subnodes, you just nest them. And so database is running on a specific machine, so you nest these, of course, and you see on which hardware, which machine is the database management system running. And you can just connect these nodes by simply drawing line. And you can also specify the protocol which is used between these nodes if you like. This usually makes sense so that you see how are these nodes communicating to each other. And artifacts, so you also have artifacts, and this is usually your application in an executable format. So is an executable file, could be a library, an archive, a database schema, so everything which you create as an artifact, which is kind of your application, right? So in an artifact deployment, you show it by drawing the artifact boxes simply inside these node boxes. So you see then if it's inside a node box, then this is where it is deployed. Let's have a look at a simple example which could be kind of familiar from your project 2. Have a look, device, you see the device marker on the left side, a desktop computer. So the first box here is your desktop computer, and inside this box is an or we say node, is another node, which is an execution environment, which is the JVM, of course. So the JVM is running on the desktop computer, and on this execution environment, you have your transport application as a component. Yes, so this is your artifact actually, which is running on that. So this component is your whole application actually. And right now, remember components, you see right now your whole application as a component running on your execution environment in this case. And you see that through HTTP, it communicates with the transport service, which is again another component. And this one is an artifact which is running on an application server. Yeah, and here we have an execution environment, a Payara server, but this could also be another server if it is deployed somewhere else. So it could be a Tomcat, a Glassfish server, an Apache server, or what else. But at least I right now simply see that this component is deployed on which server type, on which application server. In this case, Payara, but could be an Apache web server. And this thing is running on the hardware. So this is actually the server hardware, so to say. And next thing is then the database. In our case, we have 3 separate machines. And usually, locally, if you test your applications, you have everything on your machine locally running, of course. But in this case, just an example for 3 different machines. And you have then here a database server, again, as a node, a separate machine. And there is running the Postgres database on it. And inside the Postgres database, you have the transport database, so your schema, actually. And this is communicating through JDBC. Okay, so now imagine if you, in our cases, we pretty often use the Docker container. And meaning that if you have a deployment diagram and you want to emphasize that you're using Docker containers, then you have another node, of course. So you have the first node, which is the database device, so the server, database server. Then you have another one where you have your Docker container, and then you have your Postgres database, and in there then you have your transport database. So you have another one, another container, another node inside there. And this is nice, so you can easily provide an overview about the whole situation, how your application is or should be deployed, what is running where, and on really high level, what is communicating to which other node. So this is very, very nice. Let's have a look quickly again in the end, package component deployment diagram. So package diagram. So you get really a nice picture about all the dependencies between the major elements, which are the packages. This is a really nice tool for giving a nice overview about how your application is structured. For example, you show a package diagram of your backend application. So with the REST API, with the services layer, with the DAO, and you can nicely provide a nice overview how this is structured. Very nice. The second one would be component diagram. So this shows pieces of software, and the main idea here is these are independent pieces and they communicate through interfaces, remember, and the idea is that they can be upgraded separately. So you can upgrade, deploy it really separately. And then we come to the deployment diagram. This shows now really the physical layout. So where is my application, my artifact now really running? Where is it deployed, right? And this is actually a nice overview about how should, how could, how is my application deployed actually in the real world. Is this on a server? Is this on a cloud server somewhere in a virtual server? Or where? How does it look like? Very nice, very mighty diagrams. So keep these diagrams really in mind. Very usable to give a nice overview. And keep in mind that these things are really helpful for discussions in your team, with customers, with architects. So this is really a good thing if you look about getting a good architecture in place. And getting a good architecture is a thing about communication. So really helpful tools. Make use of these tools to provide a nice overview how your application is structured, how it is deployed, and how things can be independently purchased or upgraded. Have a look at the UML book, chapter 7, 8, and 14. So read in these chapters, read the slides again, watch the video again, and most important thing, make use of that. Make use of that in the assignments, in project 2. Practice with that. It is a really nice tool. That's it for today. See you next time.